Hello everyone. So today we're going to go ahead and be talking about inverse of functions. So this has been a topic that we have seen in Algebra 2. We will also see it here in pre-calculus, and it will come along throughout the year, specifically most emphasized in the inverse of trig functions, which we'll see later. But right now it's a little review of Algebra 2 skills. So let's go ahead and do this. We just learned about compositional functions, so let's go ahead and do this quick warm-up. So I'll go ahead and pause this video and solve it. Okay. Alrighty, so compositional functions, we go ahead and substitute this entire function g of x into my f of it, into my f. So pretty much I'm saying that this entire function will be substituted, right? It will replace the x right there. So I like to write the f is 1/2 big parentheses plus 4, right? I just did not write that x. Okay, so I want you to think about what's going to go inside that x, what's going to replace it essentially, which is this right here, the g function, right? 2x minus 8. And all I'm going to go ahead and do is distribute. So 1/2 into my 2. So essentially you're going to multiply 2 being divided by 2, right? Because it just distributes. It's going to be 2 over 2, which is just 1. So I'm just left with 1 times what my x carries down, minus 8 times 1/2. Pretty much 8 divided by 2 would give me 4 plus 4. Because of this 4, just bring it down. So now I have x minus 4 plus 4. Those are the same number, opposite signs, so it should be 0. So according to this, this fog, or if you are writing it f g of x, is just x. And we're going to learn something really nice about a composition of functions that ties into my inverse of functions. It's going to be some pretty neat stuff. Okay, that is for a friendly reminder of what we are actually doing this week. Alrighty, so something you need to know, and hopefully this comes back from your geometry skills, but if not, I'll talk about it real briefly, and that is when we are doing the inverse of functions graphically. So pretty much what you probably heard all your entire school days is that you swap the x's and y's. And yeah, it's that simple. So if I go ahead and give you an example right here, let's call this red one the original. Let's call it f of x. Let's assume it's a linear. So it looks something like that. If I get a point, let's get a nice point right here. If I get this point right here and I labeled it for you, 0, 1, right? 0 horizontal, 1 in height. This is my x, this is my y. And if I want the inverse, let's call it this blue function right here, inverse. It's going to be swapped. So now my y will be, I'm sorry, my x will be my y, right? And then my y will be my x. All right. So that's pretty much what you're doing for every single point. And we have another example right here. This is my x, this is my y. X was 0, I'm sorry, x was 1/2, right? Negative 1/2. Now my y is the negative 1/2. My y was a 0, now my x is a 0. So what I want you to know is that these points from the original function and its inverse are gonna be equidistant right here. They're gonna be like pretty much a reflection, of the line y equals x. And it's pretty cool. So you can go ahead and see that any point right here, let's go ahead and see, is going to be that point. It's just pretty much a reflection over this point. And that line, once again, is y equals x, that linear function. So let's go ahead and see some more examples. Oh yes, so something you also need to know is this right here. You're going to hear this a lot, and that is because, let me hide this real quick. That is because this is one-to-one functions. You're gonna hear this a lot. And in order to go ahead and see this is, you need to check that first of all, it is a function, right? So we're gonna do the vertical line test and it passes a horizontal line test. So if, what one-to-one function means is that if it passes these two, it has an inverse. So let's go ahead and do that real quick. We'll do the vertical line test, right? Vertical line test. And friend reminded us that it can only pass a function at one point. So both of these, because they are functions, they both pass the vertical line test, right? No matter what you do, they both pass the function maximum one time. Okay, so that's the vertical line test. The horizontal says that it can only pass one time. And notice this one right here. So horizontal line test, it did not pass it. How about this one right here? It only passed one time, right? So there's a horizontal line test. So what I want you to know from this is that this x cubed is 1, 2, 1, meaning you can have an inverse. So, and hopefully you guys know that the inverse of this would be that, right? But this has, well, you can find its inverse, right? So you can find the inverse of this function. How about this one right here? Well, for x squared, it did not pass the horizontal line test, so it is not 1 to 1. Okay, and the reason for it is because once you do your inverse, you go ahead and see that it looks like this parabola like that. Okay, and then that would not pass the vertical line test. So its inverse would not be a function. Okay, alrighty, let's do some algebraically, and this is where students really see more connections from the Algebra 2 days. So pretty much the steps are still the same. So swap your x's and y's and solve for y. Okay. Alrighty, so pretty much remember f of x is the same thing as saying y equals x minus 2. The first step is to swap my x's and y's. So wherever the y was, now we have an x and vice versa. And all you have to do is solve for this y. So I got x plus 2 is equal to y. We are in pre-cal, so I'm going to go ahead and tell you that there is still one more step to this, and that is to write it with the correct notation, which is my little, whatever this function was, so f, so now it's f inverse, so this little, it looks like an exponent, but it's not, it's just a symbol, and whatever we figured out was, which was x plus 2. So this is what I'm going to go ahead and encourage you is your solution. Very important that you have this symbol. Okay. So I encourage you guys to try this one. So go ahead and pause the video, give it a try. And hopefully it's not that bad. Okay. So the same thing, y equals 1/2 x minus 2. You go ahead and swap the variables. So now it's x equals 1/2 x, oops, I said x. It's not x, it should be y minus 2. And you just solve for it, guys. Don't let that fraction intimidate you. You're pretty much doing the thing. It's x plus 2 equals 1/2 y. And this scares a lot of students, but honestly, it's not that bad. When something is being multiplied by a fraction, you just have to multiply by its reciprocal to both sides. Okay. So I distribute that. Remember, this is just 2 times x plus 2 is equal to y. And you just simplify 2x plus 4 is y. Oops, and that looks pretty bad. And I'm going to go ahead and push you to write it in its correct term. So f inverse of x is 2x plus 4. That should be your solution. Hopefully you got that right. Let's go ahead and try another one. Alrighty, this one's really nice. Give me a second, where's my marker? So same thing, y equals x squared minus 16. Then I swap the variables wherever my x is. Now it's my y. Keep in mind that x was squared, so this y is squared. Okay, you do the same thing. Plus 16 plus 16. X plus 16 is equal to y squared. Okay, awesome. Now, in order to get rid of this square on the y, you get the square root both sides, and you have the square root of x plus 16 is equal to y. Something that I need you to know is that when you go ahead and square root this, make sure you put your plus and your minus, because you have your both parts of the solution, right? Because we just said the inverse of that parabola is like so, the positive side and the negative side. That's why we have to have the plus and minus. Okay, let's write its correct notation. F inverse of x is equal to my plus minus square root of x plus 16. Yay. Okay. Alrighty, one more time. So y equals square root of x minus 4. And you're just pretty much going to go ahead and simplify the best you can. Ooh, actually, I'm lying. Don't forget to swap your variables like I almost did. Okay. And you're pretty much going to go ahead and solve for y. So in order to get rid of the square root, remember that's the exponent 1/2, and I'll go ahead and square both sides. So I got x squared is equal to y minus 4. How do you get rid of that minus 4? Well, you just have to add plus 4, right? Plus 4. So I got x squared plus 4 is equal to my y. And I can write it in my correct notation, which says f inverse of x is just x squared plus 4. My handwriting gets worse when I get excited. Okay, cool. And I believe this is my last example. So as I mentioned, hopefully that was enough examples, but hopefully I mentioned that there is a unique characteristics when you do composition of functions. So I encourage you to write this down. This right here, when you go ahead and compose two functions, let's say f and g, and those functions, when you do both compositions, and they give you that the solution simplifies to x for both of them, whether it is Fogg or Goff, that means that they are inverses. So that's something very good to know, okay? So let's go ahead and try that. So we're saying that if f of g, Fogg, composition gives me x, and Goff gives me x, they are inverses. So I'm gonna put yes, inverse. Okay, don't let them intimidate you when they show you different letters for the functions. They mean the exact same thing. So in this case, we can say that f inverse of x is g. Heads up, you will be seeing this type of stuff in calculus. Alrighty, so let's go ahead and see if they are inverses or not. So we can go ahead and see that I'm going to go ahead and put for f of f of inverse, I'm going to go ahead and put it into my f. So I'm going to get all of this right here, and I'm going to substitute it and replace the x with all of this function. So I'm going to go ahead and write the f, right, which is 4x minus 1, right? And instead of writing x, I'm going to write a big parentheses because it can fit in this entire fraction, x plus 1 over 4. Okay, I know fractions are scary, but fractions are friends. And just know this 4 is on the numerator. In the denominator, you can get rid of them like so, right? Because essentially you have 4 divided by 4. That simplifies to 1. To make this a little bit prettier, let me go ahead and say that this is x plus 1. Don't forget this minus 1. So I'm left with x. So so far it is good, right? This is equals to x. So I'm just hoping that this right here also equals to x. And if they do, they are inverses. So the next one says, if I get my inverse of x, of f, and I compose it with f, right? Now I'm going backwards. I'm getting all of this into the x. So let's go ahead and do that real quick. So it's going to be my original inverse function, which says x plus 1 over 4. But I'm going to go ahead and write it again, but with big parentheses, right? Because inside those big parentheses, I'm going to go ahead and put the other function, which is this 4x minus 1, right? And all I have to do is simplify. So I should have this negative 4, I'm sorry, this negative 1 and this positive 1. They are opposite signs, same value, so they simplify to 0. So I got 4x plus 0 over 4. That's a plus, sorry about that. Then I simplify 4x over 4, which is just x. So I can see that both compositions, f fog, were equal to goff, were equal to x, right? Both compositions were equal to x. So yes, f of x and f inverse are indeed inverse functions, right? So I kind of showed you that this one did work, but essentially they will give you a function g and they'll ask you, hey, is it going to work or not? So when they both equal to x, they are inverses. When only one of them does and the other one doesn't, then they're not inverses. Okay. These are some good practice problems that are already on your notebook. This is 1.7. And just go ahead and give them a try, find out the inverses. Okay, and then exit ticket. So go ahead and try your best to do this inverse problem. So this will be your exit ticket, and that is also on your notebook. As always, it's a pleasure.